Today we will discuss the screw interpretation of a twist. Observe the figure. This is our reference frame X cap, Y cap, Z cap. This point with position vector Q. S cap, screw axis, S cap is in this direction. And we will rotate this screw, right hand screw, this way. See here, this way. So it displacement of the screw in this direction, rotation as well as displacement. So S cap, it is in this direction, same. What is pitch? Generally, we consider pitch is displacement of the screw per one revolution. But in modern robotics, pitch is defined as displacement of the screw per one radian angle, not one rotation. Again I am repeating, pitch is the displacement of the screw per one radian measure of the angle. So pitch h equal to, it is denoted h, is linear speed upon angular speed. Why? We will discuss in our video. Now see the figure. This is the position vector Q and this is the screw axis, and we are rotating this way. Figure 3.19, a screw axis represented by a point Q, a unit direction S cap and pitch h. The pitch, it's class 4 unitary method. For 1 radian h meter. So d theta by dt into t, in time t this angle is covered, angular velocity into time t. So for this radian, how much? Suppose this one is question mark, suppose this answer is suppose x. So x is this into this by this. So x is h into d theta by dt into t by 1 radian. Now readjusting the term t here, h d theta by dt, x by t is h d theta by dt, x by t is h d theta by dt, and then after subtracting h, we get x by t upon d theta by dt. X by t is the linear speed, d theta by dt is the angular speed. So pitch is defined as linear speed upon angular speed. Now screw axis, see here, screw axis, big S, is the collection of Q, S cap, H. Q is the position vector of point where we are applying screw motion. S cap is the screw axis and H is pitch. So twist is denoted as omega V. Omega is angular speed, V is linear speed, angular velocity, linear velocity. Angular velocity is S cap into theta dot. Theta dot is d theta by dt, and V is minus S cap theta dot cross Q plus H S cap theta dot. So V is addition of two velocity. This one is linear velocity, this term screw, advancement of screw, and this is due to rotation motion. So here h s cap theta dot, it is due to the translation along the screw in 1 second. It is the displacement of the screw in 1 second. Omega is theta by t, we will derive it. Omega is theta by t implies theta is omega t. So in t second, 1 radian h s cap, because of 1 radian is h s cap. So in t second, theta into h s cap displacement is there. So in 1 second, how much? So question mark is theta h s cap equal to upon t. So h s cap theta dot, theta by t is d theta by dt, it is denoted as theta dot. So this one is h s cap theta dot. This is a unitary method, but we must understand this. Now this term, this velocity is made of two. This is linear velocity of the screw and this is due to rotation motion. So minus s cap theta dot cross q, it is due to linear motion at the origin induced by the rotation about the screw axis. See here, a screw is rotating this way. So what about the velocity of the origin of reference frame, this original reference frame, due to this rotation? So omega is this, in this direction. If you consider reference point here, this vector is minus q, this vector is omega. So omega cross minus q. Again I am repeating, consider this as a reference point and we are rotating this point this way. So omega is in the direction of s cap. So omega is s cap and this vector, not this vector is minus q. So omega cross minus q this way. Again I am repeating, omega cross minus q this way. This is the velocity of the reference frame origin. This one. According to how we can obtain V is omega cross R, simple formula. So here omega is s cap theta dot, our representation, and R is replaced by minus q. So V due to rotation, this part is s cap theta dot, because of omega is this, cross R, but R is minus q. So it is minus s cap theta dot cross q, this one. Okay. Here s cap, direction of screw axis, it is unit vector in the direction of omega. So omega upon mod of omega, mod 2 times because it's matrix, and omega is determinant. So determinant magnitude is maybe minus, so double modulus. Theta dot is mod of omega. Now component of V, this is actual velocity, total velocity, this one. See this one, it is the addition of these two, this one. So component of V in the direction of omega, we have studied. So it is V dot omega upon mod omega. Scalar component of V in the direction of omega is V dot omega upon mod omega. This is the definition for component. So omega by mod omega is omega cap. So V dot omega cap. But dot product order is no important. So omega cap dot V. But here omega cap, here in terms of matrix, it's a column matrix. So we should convert into row matrix. So it is omega cap transpose into V. In modern robotics, we will study all the matrix, vector matrix, column matrix. So we want to convert into row matrix. So transpose we have taken. Now this one, omega is theta by t, theta is omega t, but for t equal to 1, theta is omega. So for theta radian in 1 second, the advancement of this screw in the direction of omega is omega cap transpose V. So for 1 radian in 1 second, what is? And this question mark is nothing but pitch. So question mark equal to pitch, which is omega cap transpose into V divided by theta. So omega cap transpose into V, and but theta is omega in our case because we have taken t equal to 1. So mod of omega. This one is pitch. Now we will revise our knowledge. Do you know what is radian? Measure of an angle. And 1 radian equal to how much degree? See the figure circle. This one is reference line, and if we move from this point, starting point, whole circle, the total angle is 360 degree. For 360 degree, corresponding arc length is 2 pi r. So for theta degree, this much. Theta degree, how much? So question mark equal to, it is the length of the arc of the circle. Say L, it is 2 pi r theta degree upon 360. So pi r theta degree upon 180. the formula for arc length for degree measure. Now for given particular angle, see the figure, this is the theta degree, this arc length is L and corresponding radius is R, this arc length is L dash and corresponding radius is R dash. But for given particular angle, ratio will be same, L by R, L dash by R dash, these two ratio same because of angle is same. So what is L? Using this formula, L is pi r theta degree upon 180 divided by R, so R are cut out. So we have the formula, conversion formula, radian to degree, degree to radian. Theta radian is pi theta degree upon 180. Now for 1 radian, put theta is 1 and subject theta degree. We get theta degree equal to 1 radian into 180 upon pi. So degree measurement of 1 radian is roundabout, because the pi is 3.1415926 something, it's an irrational number. So this is also irrational, or it is 57.3248 something degree, nearly 60 but not 60. This is 1 radian. Okay. If omega equal to 0, then the pitch h of the screw is infinite, because of v is not 0 but omega is 0. So we can consider for very small angle theta nearly 0, v is there, so pitch should be infinite. In this case, S cap is chosen as v upon mod of v because of omega is 0, and theta dot d theta by dt is interpreted as the linear velocity mod v along S cap. Instead of representing the screw axis as using the cumbersome collection q s cap h, with the possibility that h may be infinite, and with the non-uniqueness of q, any q along the screw axis may be used. We instead define the screw axis as using a normalized version of any twist equal to omega v corresponding to motion along the screw. A, if omega not equal to 0, then screw axis is twist by mod omega, but twist is omega v, so omega by mod omega, comma v by mod omega. The screw axis S is simply twist normalized by the length of the angular velocity vector. The angular velocity about the screw axis is theta dot, it is mod of omega, such that as theta dot is twist equal to, we are multiplying by theta dot, so omega cuts out, so omega comma v. B, if omega is 0, then S is denoted as twist upon mod v, but omega is 0, so first element is 0, comma v by mod v. The screw axis S is simply twist normalized by the linear velocity vector. The linear velocity along the screw axis is theta dot, it is mod v, such that S theta dot is twist. This leads to the following definition of a unit normalized screw axis. Definition 3.24. For a given reference frame, a screw axis S is written as S equal to omega v belongs to R6. Whether either 1 mod of omega 1 or 2 omega equal to 0 and mod of v is 1. If 1 holds, then v is minus omega cross q plus h omega, h is pitch, where q is a point on the axis of the screw and h is the pitch of the screw. H equal to 0 for a pure rotation about the screw axis, no displacement. If 2 holds, then the pitch of the screw is infinite because of omega is 0 and v is not 0, and the twist is a translation along the axis defined by v. Now, important statement, although we use the pair omega v for both the normalized screw axis S, where one of mod of omega or mod of v must be unity, and a general twist where there are no constraints on omega and v, the meaning should be clear from the context. Observe the whole video. Since a screw axis S is just a normalized twist, the 4x4 matrix representation this of S equal to omega V is matrix representation of screw axis is omega skew symmetric omega V 0 0 belong to SE3. Skew symmetric omega is 0 minus omega 3 omega 2 omega 3 0 minus omega 1 minus omega 2 omega 1 0 belongs to S 3.85, where the bottom row of S consists all zeros. Also, a screw axis represented as SA in a frame A is related to the representation of SB in a frame B by SA equal to adjoint representation of TAB into SB equal to SB and SB equal to adjoint representation of TBA into SA. Subscript cancellation rule, BB cut out. Here A cut out. So this one.